Good day to the doctor and everyone. My name is Tan Zhen Wang. Today I'm going to do the assignment question 1 presentation for the subject PLC and automation, and I am from lab group 13. And here Samir bin Kahat Tan Kaling Quek Mohammed is my team members. For our group, we use the smart tissue dispenser as our topic. Smart tissue as dispensers can reduce the potential of cross-contaminations. Dispenser completely enclose the tissue so the user can only touch the tissue when they are going to use. The objective for this subject is to control the rolling of the tissue to dispense out of the tissue box. This project is based on sensor, LED, and the motor. When the sensor will detect the hands move closer, and then the tissue will automatically grow downward, and then the green LED light will be light up, and then after the tissues is finished, the red LED will be light up, and then this is how our project is operate. So this is our smart tissue dispensers CAD design. Look at here, you can see that the dispenser with a lock on the top, and then the back and installation details, and then you can see from the side shape, and then here is the induction area, and it's also the paper acid area, and then this is the inside structure. Okay, now this is our flow chart. From this flow chart, the user must switch on the power supply to start the project. If the tissues were out, the green LED will be light up. If the tissue overflow, we have to manually adjust the tissue well. However, if the tissue cannot go out, and the red LED will be light up, and it means that the tissue was empty and we need to repress it. Okay, so for the next, this is the ladder diagram for our smart tissue dispenser. Okay, to operate the okay, we open here. Okay, to operate the whole system, start button 0.00 was closed at the beginning. The motor at the same run will be energized. A stop button will located after the start button in order to stop the whole system when emergency happens. When the sensor here sense the assistant of hand approach, normally open contact of it become closer, and the counter will be increased by 1. When the sensor sense one time hand approach, one paper will be dispensed out. Okay, after 2 seconds using this timer, 2 seconds when the sensor sense another time the hand approaches, the paper will be dispensed out again. So here the LED green LED will be also light up. Okay, what if after 100 times the paper out easy, and then the red LED will be light up, it means that the tissue was empty, so we have to repress it. Okay,
Hi everyone, my name is Gretchen Tangaling. I'm from 2BKS1, and today I'm going to present our assignment for PLC automation. Okay, in my part, I'm responsible for shift register method for question 1. So without further ado, let's go straight to the things. Okay, first I will discuss the methodology. Okay, the shift register method we use. Okay, for question 1, we would like to use the Omron's PLC CS programmer software to construct the system for this automated tissue dispersal. Okay, dispersal. Okay, and in this automated tissue dispersal, the component used like start, stop, sensor, motor, green LED, red LED, counter, timer. Okay, to be used in the ONMON PLC CS programmer with shift register method. Okay, why do we use shift register method compared to conventional method? Of course, conventional method is more easier to the circuit is simpler and more easier to reconstruct compared to shift register. But shift register, the advantages of shift register is more in sequence. Is in sequence and step by step in sequence and systematic in the way of programming and suitable for sequence process and easy for troubleshooting. Okay, it is more mostly used in industrial. Okay, industry. Okay, for our automated tissue dispersal, we will discuss okay the structure and the process. Okay, first the start button is pressed and then the motor will be initialized, and when a hand is approached to the automated tissue dispersal, the sensor will sense and give a signal to produce out a piece of tissue. Then the green LED light is turned on once the start button is pressed, and the counter will start counting for its dispersal of tissue until 100 count. Okay, then when 100 count is reached, the red LED light will turn on for indication of lack of tissue and in need of tissue replacement. Okay, next we direct to this is our the automated tissue dispersal structure picture. Okay, and we'll go to the CS programmer for our shift register system. Okay, so first I will compile and work online for simulation. Since I already okay, it's already turned on and we set on. Okay, this is shift register move. We will need this by using this new PLC instruction. This instruction to set the 0 to 1 bit. This is the symbol of shift register. Then P dash off. Okay, we need this to add only the new 0 to first bit. Okay, and this is shift register instruction. So we set H0 as our destination. Okay, this is the pulse, and this is stop 0.01 is the input. Okay, we have 7 steps. First step, H0.00 start. Then you can see this blinking is the pulse. Okay, start. Then the second step, the motor is initialized. Then the third step is the sensor will sense when there is a hand approach. Okay, then the timer will count for 2 seconds, and the green LED will turn on for 2 seconds when there's hand approach. Then the counter will start counting when the tissue disperse out and the 100 count. Then the red LED light will light up, means indicate that need of tissue replacement. That's all. So this is the step 1. Motor, proximity sensor. This is the timer. Green LED, counter for 100 count, red LED, then finally stop. That's all from my presentation. Thank you very much.
Okay, Assalamualaikum to Dr. Faris and also watching this. My name is Shamil bin Kaha and I am from 3BKMS1. So for my part, I will explain about question 2 for the assignment. So from the question given, we can state that this is the sequence of the operation. Okay, firstly, when the start button is pushed, the conveyor A will run until sensor 1 detect the object. And after that, the cylinder will turn on for 5 seconds for stamping operation. After that, cylinder will extract until it touch reed switch. After the reed switch is triggered, the conveyor A will move again until it touch limit switch. And a conveyor A will keep moving while ejector will operate for 1 second to push the object to conveyor B. Okay, so when the object already on the conveyor B, sensor 2 will detect object and conveyor B will start moving until the sensor 3 detect the object. Okay, after the sensor 3 detect the object, the spray nozzle will on for 30 seconds while the conveyor B will stop for 30 seconds. Okay, for the spray nozzle will operate 30 seconds and after 30 seconds the conveyor will continue moving until the end of operation. Okay, so that's roughly about the sequence, and here is the ladder diagram. So we are using shift register method. So here, okay, firstly we compile the simulation and we turn on start to give a pulse, we turn on and turn off right, and it gives a pulse to the H00. So for H00, it will turn on the conveyor A. As the first operation, the conveyor A will move. And after we give another pulse, the cylinder will turn on for 5 seconds. So here counting until 5 seconds, and it will extract until it touches the reed switch. So we give another pulse. Okay, so conveyor A will move again until it touches the limit switch. So here limit switch. Okay, so we give another pulse. Okay, so for the next operation, the conveyor A will keep moving while ejector operate for 1 second. So you already finished counting because it was only 1 second. Okay, so we give another pulse. So after that, the sensor 2 will detect object and conveyor B will move. So here conveyor B will move and it will move until sensor 3 detect object. So here sensor 3. So give another pulse. Okay, so sensor 3 detect object and spray nozzle will operate for 30 seconds. So here it's counting for 30 seconds. Okay, it already finished counting. So after 30 seconds, you can give another pulse to see for the next operation. Okay, for the next operation, the conveyor B will move again and it will stop until the end of operation. Okay, we give another pulse to see it move to the end of operation. Okay, here we can see the end switch and it already turned off and no more operation. So that is how it works for the ladder diagram. So thank you so much. So that's all for my part.
السلام عليكم ورحمة الله وبركاته and good evening tutor. I am Kaid Muhammad Uthman Ahmed from BEKM section 1. Today I am going to discuss some parts in assignment question 2 by using shift register method. I need to construct the start and the completion table before I draw the later diagram. Start and completion table. Conveyor A will move until sensor detect the object at 0.06. When object detect the campfire A will stop to give time for stamping. So stamping down by a single acting for 5 seconds, and the timer will activate and timer will activate. When timer complete, single acting will be off until touch read switch at 0.07, and conveyor A will move until touch limit switch at 0.08. Conveyor A move and ejector for 1 second, and timer 3 will activate. When timer 3 activate, conveyor B will be on uh, until sensor 3 detects the object. When the sensor 3 detects the object, spiral nozzle will be for 30 seconds, and timer 4 will activate. After the timer 4 complete, after timer 4 complete, conveyor B will take the object end uh, into the end station. The system consists of input and output. Input such as switches and sensors, and output such as conveyors and ejector and the spray nozzle, as well timers. That's all, doctor. Thank you so much.